Hey CMA buddies, let's today start with a new chapter that is 9.3. This talks about data organization and distribution. Fine. So let's understand what is data organizing. Organizing of data simply means a process of organizing data by classifying them into different categories. So when a data is being categorized into different categories, that is called as organizing of data, right? For example, you arrange the marks by students in different subjects. So for example, there are 2 or 3 subjects, say maths, Hindi, English. So if you just categorize them into different marks they have scored, for example 10, 12, 15, this is out of 20. Similarly 15, 17, 9. So this is basically a kind of organizing the data. So organizing of data simply means classifying them into different categories, right? Okay, it is a process of arranging unstructured data in a meaningful manner. So basically you can have simply as to how much marks they have actually scored, but if you arrange this unstructured data in a proper format, that simply means organizing of data. Now before we move on, we need to understand what's the difference between a structured data and an unstructured data. Structured data simply means it consists of tabular information. So this is basically tabular information. This is more of a kind of a structured data that can be easily imported to a database. So that can be brought into a database easily and then utilized by analytic software or other applications. So basically analytic software can utilize it and use this structured data for whatever information it can be converted into proper decision making, right? So that's what structured data talks about, whereas unstructured data is basically raw and it's unformatted data. So simply if I say he scored 10 in maths, doesn't speak much, so that is more of an unstructured data. But when you culminate this unstructured data into more organized form, that becomes a structured data. So unstructured data are raw and unformatted data. This can be basic text such as documents with names, dates and other information which are random. So they will be more random. So random is the key word here, right? So what we have studied till now, we have just read what is organizing of data. It simply means classifying them into different categories. It is a process of arranging unstructured data in a more meaningful manner, or you can say process of arranging unstructured data into a structured data. What is the difference between both? Structured data simply says consists of tabular information that can be easily imported to a database and then utilized by the analytic software or other applications for proper decision making, whereas unstructured data simply is raw and they basically are very unformatted, like basic text documents with names, dates and other information which are very random, right? Okay, let's move on. The next topic that we are going to discuss, we will be talking about data distribution, right? So distribution simply refers to how data is spread out, right? How do you distribute it? Or clustered, that means they are accumulated around certain values or ranges, right? So what is distribution? Distribution basically refers to how data is spread out. Basically it's being distributed or being clustered, that is they are brought together around certain values or ranges. How does it help? We can get insights into characteristics and patterns of data. So they help us to know various characteristics and the patterns of the data, which can help us in what? Decision making and making predictions for the business, right? So distribution simply means how the data is spread out or clustered around certain values or ranges. This can help us to get insights into what it can get. It can help us to get insights into characteristics and the patterns of data, which will eventually help us in decision making and making predictions for the organization, right? Okay. Benefit of data distribution is estimation of probability, because how do you make predictions? You can make prediction on the basis of probability, right? So benefit of data distribution is estimation of probability of certain observations within a sample space. So if a sample space is given, you make an estimation of the probability. If you have studied probability in class 11th and 12th, you would be able to correlate it in a better way. Even if not, that's fine. It simply says benefit of data distribution. The data distribution that we studied here, it's basically estimation of probability. So you would see how the event, what are the chances of success or a failure, that is called as the probability of an event, and within a certain range, that is called as a sample space, right? How do you do it? This is basically done in the form of histograms, box plots and pie charts. So these are various ways of doing data distribution, right? So let's come to type of distribution. Now this type of distribution is basically categorized into two. They are basically categorized into discrete distribution and indiscrete distribution, right? Let's start with the discrete distribution. Discrete distribution. Discrete simply means something which is separate or divided, right? So discrete means something which is separate or divided. Don't confuse it with discrete, that is CREET, that means secret or hidden. This is discrete, CRETE. DISCRETE, this simply means something which is separate and divided. Okay. Now the first and foremost things that you need to remember with respect to discrete distribution is this basically results from countable data. So if it is countable, then it obviously has to be a finite number, and it talks about certain potential values. So any result from countable data and has a finite number of potential values. So that means the other one, that is indiscrete, that we are going to study, that will be more to do with infinite and uncountable data, right? So let's look at an example. It may be displayed in various tables and value of random variable, and that can be counted. Yes, because they are countable, so it can be counted, and they are finite in nature. For example, rolling dice. Now if you roll a dice, you can get only from 1 to 6. So this is basically more of a discrete data. That's an easier way of understanding it, right? Okay, let's come to various types of discrete data. The first one we talk about is binomial distribution. Okay, binomial distribution simply says chances of obtaining specific number of failures or success in each experiment. Very simple. Binomial means 2, right? Bi means 2, right? So it simply says chances of obtaining specific number of failures or success in each experiment. So these two things are what? There are failures and success. So if a distribution talks about the failures of success in each experiment, then obviously we are talking about the binomial distribution, right? Now they are basically categorized into two mutually and exhaustive classes, such as number of success and failures or number of acceptance and rejections, right? Before we move on, let's understand what do you mean by mutually and exhaustive classes. Mutually and exhaustive classes simply means they can't occur both at the same time. And that's very obvious, right? For example, if an event is happening, right? So either you can have a success or a failure. It cannot be both. Similarly, if it is an acceptance or it is a rejection, it cannot be both. So that is what it is. Binomial distribution categorically talks about mutually and exhaustive classes, right? So binomial distribution simply means chances of obtaining specific number of failures or success in each experiment categorized into two mutually and exhaustive classes, such as number of successes, failures, or number of acceptance or rejections, right? For example, tossing of a coin. So what do you do? If you toss a coin, either you get a head or a tail, right? So likelihood of heads is 1 by 2 and the probability of tail is 1 by 2. So this is a perfect example of binomial distribution, right? So we started off with types of distribution. First one we talk about is discrete, and in discrete distribution, the first one we spoke about is binomial distribution, right? The second one is Poisson distribution, right? Probability distribution, that is used to show how many times an event is likely to occur over a specified period, right? You just need to check how many times, if an event is occurring, then in a specified period, how many times it takes place, right? So probability distribution simply talks about how many times an event is likely to occur over a specified period, right? Where does it applies to? It applies to attributes that can potentially take on huge values. It basically can be applied to attributes that can potentially take on huge values, but in practicality it take on the tiny ones, right? So basically it can be used for huge events, whereas in practice it is only taken on the tiny ones. For example, number of mistakes or accidents or absentees, etc. This is a perfect example of Poisson distribution, right? So Poisson distribution simply talks about how many times an event is likely to occur over a specified period. Where does it apply? It applies to attributes that can potentially take on huge values, but in practice they take on only the tiny ones, right? Example can be number of mistakes, accidents, absentees, etc. Right? Let's move on to the next one. Next one talks about the hypergeometric distribution. What is hypergeometric distribution? Selections are made from two groups without replacing members of the group. So if selections are made from two groups but their members are not being replaced, right? So for example, there is one group which has A, B, C, D, and the second group has, say, D, E, F, G. In that case, the selections have to be made from these two groups only. you cannot replace any of the members of this, right? Now the perfect example can be a random selection of members of team from a population of girls and boys. So you have to make a selection which has to be random from a team of a population of girls and boys. So they are the set of girls and boys. You cannot replace these girls and boys. From them you can select whatever you want, right? So that's what it talks about. That is what is hypergeometric distribution. So hypergeometric distribution concentrates on the fact that basically the selections are made from two groups, right? So it focuses only on two groups without replacing the members of the group, right? Now there is a certain difference between hypergeometric and the binomial distribution, right? Because they both talk about two only, but there is a certain difference between both of them. The chances of success is not the same for all trials in binomial, whereas it is same in case of hypergeometric, right? So the core difference, please remember, it can be a question in your exam. The simple difference between hypergeometric and binomial is chance of success is not the same for all trials. Chance is not the same in case of binomial, whereas in case of hypergeometric, whereas it is the same in hypergeometric, right? So that's the core difference between hypergeometric and the binomial. Finally we talk about the last discrete distribution, that is called as geometric distribution. Geometric distribution assesses the probability of occurrence of the first success as to when the first success will actually appear. So that's what is geometric distribution all about. For example, if a dice is thrown repeatedly until the first time a 3 appears. So for example, you are trying to get 3 on your dice, so you keep on throwing the dice. The first time you get a 3, that becomes a geometric distribution, right? So assess the probability of occurrence of the first success. So the key word here is first success. So you keep on trying unless and until you get the first success. So throwing a dice, you want a 3, when you get the 3, that becomes a geometric distribution for the first time. Please remember the core word here is first success. Similarly, you are looking for a representative you are basically representative from an advertising agency. You have to choose a hockey player from several institutions, but your agenda is to get one Olympic participant, right? So you keep on looking at various hockey players from different institutions till you find the first Olympic participant. So the first time you find the Olympic participant, that becomes an example of geometric distribution, right? So geometric distribution simply talks about assess the probability of occurrence of the first success. Example, if a dice is thrown repeatedly until the first time a 3 appears, or you can say a representative from an advertising agency chooses hockey players from several institutions till he finds an Olympic participant, right? Okay, now we come to the next one, that is called as a indiscrete, or the word that we use here is continuous distribution. So the first type that we did was what? The first type we did was discrete distribution. The second one we are talking now about is continuous distribution, right? Okay, what does continuous distribution says? It is one in which data can take on any value within a specified range, which may be infinite. Now again, this talks about the specific range. Only difference between the discrete and the continuous is discrete talks about finite or the countable value, whereas the continuous one talks about the infinite one, right? It is one in which continuous random variable x can take any value within a given range of values, which can be infinite and therefore uncountable. So the key word here will be infinite and uncountable, very unlike what we did in discrete. So basically continuous is opposite of what we did in discrete, right? So continuous distribution is what? It is one in which data can take on any value within a specified range. This can be infinite. It is one which is in which a continuous variable, random variable x can take any value within a specified range of values, which can be infinite and therefore uncountable. Now the perfect example of this can be time is an infinite because you could count from 0 to billion seconds, right? The range is limited, right? You have only from 0 to 60, right? But if you talk about minutes, but this can be billions of value in between, right? So that's what is continuous distribution all about. Time is a perfect example of it. Now, how can time be infinite? Time is infinite because you could count from 0 to billion seconds, trillion seconds, so on and so forth, right? So the clock itself can be distributed into various seconds. So that's what continuous distribution talks about. Now it is described using probability density functions, right? PDF, not the one which we use for data and all. PDF simply for your remembrance I have written it as, it is described using probability density functions. Fine. Okay, so if someone asks you what is described using probability density functions, then you have to say it is a continuous distribution, right? Okay, let's come to various types of continuous distribution. The first one we talk about is normal distribution. Okay, now normal distribution have two words, or they are called in two ways. It can also be called as Gaussian distribution or a bell curve, right? So normal distribution can be called as Gaussian distribution, Gaussian distribution, or the bell curve. Now this basically has a greater frequency around the core point, right? Just look at this picture. You would feel this is a perfect example of normal distribution. Here you can see that there is a greater frequency. This is the frequency that it is talking about. Now the frequency is highest at the core point or the center point. As value goes away from the core point on each side, the frequency drops significantly. So you could see that as and when the value goes away, this value is reducing. So here if it is 6 and here it is 1, as and when we keep on moving away from the core point, the frequency also drops significantly. So that's what normal distribution talks about, right? Okay, now next come to the next one. Next one, it talks about the log normal distribution. Okay, what is log normal distribution? Log normal distribution can be formed from a normal distribution. Again, it is a kind of normal distribution only. Only difference between both being, here you use the logarithmic mathematics. You would have studied log in 9th and 10th. So in a log normal distribution, it is again a kind of normal distribution only difference being this use your log mathematics, right? Okay, one of the most common application where log normal distributions are used in finance. So where do you use it in finance? In the analysis of the stock price, right? For example, you can say that potential returns of the stock can be graphed in a normal distribution. So if you talk about the returns of the stock, right? For example, it has given 10%, 20%, whatever returns it has given, that can be expressed through normal distribution. Whereas the prices of a stock, however, can be graphed in a normal distribution. So I hope you understand the difference between both. In a what is log normal distribution? Log normal distribution simply is a normal distribution by using logarithmic mathematics, right? It is the most common application. Where is it mostly used as far as the finance is concerned? You basically used in the analysis of the stock price, right? For example, the potential returns of the stock can be graphed in normal distribution. So when you talk about the returns part can be figured out through what? Through binomial distribution. Whereas if you talk of, normal distribution, I'm very sorry, it's about normal distribution. Whereas if you have to talk about the prices of a stock, in that case you got to use the log normal distribution, right? Okay, then you come to something called as an F distribution. What is F distribution? F distribution stands for a person called as Fisher, right? He was the one who found out this type of distribution. Fisher says basically this distribution technique is used to study the behavior of two variances, right, from random samples taken from two independent normal population, right? So basically you compare what? You study the behavior of two variances from random samples taken from two independent normal populations. So keyword here is two variances and from two independent normal populations, right? F distribution is an asymmetric distribution, right? It doesn't have a symmetry, it is asymmetric, and it doesn't have any maximum value or a minimum value of 0, right? I'm sorry, it doesn't have any maximum value, but its minimum value is 0, right? So what is F distribution? It is basically developed by Fisher. It's basically to study the behavior of two variances from random samples taken from two independent normal populations, right? F distribution is basically an asymmetric distribution. It doesn't have any maximum value, whereas the minimum value is 0. For example, in case of finance, it is used to test whether the variance of stock returns are equal across two or more portfolios. So basically, if you need to check whether the variances of stock returns of two portfolios are equal or not, that you can check with the help of the F distribution, right? Okay, then you come to something called as a chi-square distribution. CHI is chi-square distribution. Chi square simply means chi-square distribution if it can be written as a sum of squares of independent standard normal variables, right? For example, 1 square plus 2 square plus 3 square, so on and so forth. If it is expressed in this format, in that case it becomes a chi-square distribution. So a random variable has a chi-square distribution if it can be written as a sum of squares of independent standard normal variables, right? So sum of squares, that's the keyword that you got to remember. Sum of squares of what? Sum of squares of independent standard normal variables, right? Distribution of chi-square values is symmetrical Distribution is symmetrical, right? It's very unlike the F distribution where you would have seen it was an asymmetric distribution. Whereas in chi square, it is basically a symmetrical distribution and it is basically constrained below 0. Right? So what is chi square distribution? A random variable has a chi square distribution when, if it can be written as a sum of squares of independent standard normal variables, distribution of chi square values is symmetrical and constrained below 0. Right? Okay, then you come to something called as an exponential distribution. Exponential distribution is a process in which events happen continuously. It is exponential. Exponential simply means that keeps on happening again and again. So if events are happening continuously and independently at a constant average rate. So the keywords here are happening continuously, events happening continuously, independently, at what? At a constant average rate. In that case, it will be called as an exponential distribution. Example can be amount of money spent by a customer on one trip to the supermarket follows an exponential distribution. Right? If you go to a supermarket, in that case, you keep on spending continuously. It is independent also, but it is basically at a constant average rate. So a perfect example is amount of money spent by the customer on one trip to the supermarket follows an exponential distribution. Okay, please remember it is also used to represent products with a consistent failure rate. So something which has a consistent failure rate, in that case exponential distribution will be used. Right? Please understand exponential and Poisson distribution are closely connected. Poisson distribution, if you remember, where we do Poisson distribution. Poisson distribution is basically the distribution that is used to show how many times an event is likely to occur over a specified period, right? Similarly is the case with exponential distribution. Only difference is that is a kind of discrete distribution, whereas this is a kind of a continuous distribution, right? So exponential and Poisson distributions are closely connected. It has a constant failure rate since its form characteristics remain constant. Why it has a constant failure rate? Because its form characteristics remain constant. Because its form remains constant, hence it basically has a consistent failure rate or a constant failure rate, right? Finally, we come to something called as a t-student distribution. T-student distribution is a way of describing data that follows a bell curve. Bell curve very similar to what we did in normal distribution, right? So again, t distribution also follows a bell curve when plotted on a graph with the greatest number of observation close to the mean and fewer observation in the tails. So very similar to what we did in normal distribution. So t-student distribution simply means way of describing data that follows a bell curve when plotted on a graph with greatest number of observation close to the mean and fewer observation in the tail. Substituted for the normal distribution when the standard deviation cannot be determined. So the only difference between normal distribution and t-student distribution is their definition remains the same, but you just need to mention that they are substituted for normal distribution, in which case when the standard deviation cannot be determined. So if a standard deviation cannot be determined, in that case you can be using the t-student distribution. That's the difference between normal and the t-student distribution, right? Okay, now let's quickly revise what we have done. We did what is basically organizing of data. Then we spoke about the structured data and the unstructured data. We spoke about data distribution, what exactly it is. Then we did two types of data distribution. One was discrete and the second one was continuous distribution. What are the different kinds of discrete distribution? One is binomial, then Poisson, hypergeometric and geometric. And in continuous distribution, we had something called as a normal distribution, log normal distribution, F distribution, chi-square distribution, exponential distribution, and t-student distribution, right? So with this, we finished 9.3. In the next video, we would be finishing 9.4 and the MCQs on the back of your book. So that's all about today's video. If you like this video, please press the like button, share with your friends, and make sure that you subscribe to my channel, right? Thank you so much and happy learning.